Okay, so I'm starting with this topic which we are going to cover is evolution of Earth or Earth history, origin of Earth, things like that. So these are very basic, fundamental philosophical questions, right? I do not know. Of course, nowadays kids are much more smarter. They are much more aware. They are much more vigilant, right? And they know their purpose also in majority of the cases. So I'm sure that to many of you these questions must have occurred. Who am I? Right? Is that a good question? How many of you can have thought about it, and how many of you are thinking about it now? And how did you answer it? Okay, no issue. Where have I come from? Right? So this can be. It has nothing to do. All these questions have nothing to do whether you are a person or whether you are an object. Whether you are a person from one religion or some other religion, or whether you are if animals, I'm sure animals think right about themselves, and animals also have power to remember things and to do a lot of things, right? So these questions must be coming to almost everybody, whether living being or non-living being. Of course, more to do with living being. And I consider myself Earth as living being. So, imagine if you are an Earth, right? You are Earth, and you are asking yourself, because that's how I'm coming to the topic, right? Who am I? Where have I come from? What is my origin? What is my destiny? How will I end? Or मेरा हास्य क्या होने वाला है आगे आने वाले time with so much of activities, anthropogenic activities, pollution, exploitation. What is my destiny? Am I alone here? Is Earth a unique planet?
Yes.
So is Earth alone here in this universe? Sorry? As far as we know, right? So we have limitation in our knowledge, and that's the reason. That's one of the reasons because of which we do so much of space exploration to know if there's any other planet which is similar to Earth where we can do some habitation, where we can do some exploitation as well. How does the system work? We take things for granted. All the natural environment around us, all these natural resources around us, we take them for granted. And that's why we sort of exploit them, if I can say so. But how does the system work? Whether it's a process of any dynamic process, for example, earthquake or cyclone or any system. How does it work? What are those components? What are the physics? What are those ingredients involved in it? And why should I know that? And how should I know that? Right? So, and of course, what is my destiny is same as what is my future. So now these are the questions which you could be asking yourself, and as an Earth could be asking, to itself, and that's what we are trying to address here. To know more about Earth, to know its origin, to know about how does it work. Okay, so now coming to the topic straight away, the usual questions now, that's from philosophy. Let's come to the topic. So the important questions before us are: when was Earth born? Anybody has any idea? Please.
Earth was formed as a result of the Big Bang.
No. When was it born? When was Earth born?
Approximately 4 billion years ago.
4?
Billion years.
Which is what? Billion means what? Billion means what?
Oh, you want to understand 20 the billion. 4 into 10 raised to power 9.
Very good. Very nice. Very nice. Right. So, and when was the universe formed?
Around 14 million. 14 billion.
Oh, good. So you are all well aware. Very nice. Very nice. Very nice. When did life begin on Earth? When did plate tectonics, one of the most fundamental, most applicable, most sort of well understood process, and one of the most a process which helps in knowing so many things, whether it's mineral resources or whether it is earthquake hazard assessment or anything else. Plate tectonics is one of the most fundamental process which operates on Earth. So, any idea when did plate tectonics start on Earth? Of course, it's a tough question. Then, when did human appear on Earth? So, first is life, and then human. हम लोग कब आए? You need to visit the Museum of Body Institute of Himalayan Geology. Right? We have a very good museum, and it displays lots of rocks. It displays a lot of fossils of early life, fossils of later life, mammals, and even our own ancestors. So I will strongly suggest that you should certainly go there. This is a very beautiful picture which looks very fascinating, and it contains millions of information because it contains millions of years of history as well. So at the center here, so that's the origin of Earth, 4.6 billion years, right? That's when the Earth actually started, probably started. We have fairly good idea about this age. 4.6 is fairly good. Rest of things, whether life or whether it is plate tectonics or whether it is single cell life, we have some debate as to where actually it started. But as far as formation of Earth is concerned, we have fairly good idea. And what you see here, if you zoom this picture is if you Google, it's there on Wikipedia as well. So it shows a lot of things here. It shows a time scale. It shows time scale in terms of billions of years. It also shows what happened during the evolution of Earth, when Earth was born, and how things started happening. So it says that about 2 billion years ago, which is here, that's when probably the single cell life started. Those amoeba. I'm not from biology background. But then there was a large period which was during which the life was evolving very, very slowly. It didn't happen in all of a sudden, right? Of course, in geology, everything is measured in millions or billions of years, and we don't talk in terms of years. We don't talk in terms of days. So for us, a few million years is a very young age, right? Himalaya is very young, although it's 50 million years old, but it's very young. That's how we think. So then, let me show you a picture from here, right? So this is a picture which is there on the Martin Institute of Biology Museum. This clock, and this clock shows that the evolution of life on Earth. And what does it show? That look, around 200 billion years, single cell animals they started, and the real life, the good life, started sometime around 500 billion years back, right? If you look at here. Now this is a non-linear scale, so this is in terms of billions of years, but then I'm coming to millions of years. Okay? So this is a clock which has been divided into 24. Yeah, please.
So did life begin from the ocean?
Oh yes, of course. Yes, of course. That's absolutely right. So that's the reason because of which, if you look at, you can use the pointer, yes. So if you start from here, so this is all blue here, at least till here, right? So this all shows that look, this was all this life was basically under ocean. So life actually evolved in the ocean, and in most likely cases, the life actually started somewhere where the water was hot. There were hydrothermal vents. There was a lot of nutrients, right, available. That's where probably the life started. Okay, so this is till 500, or let's say till 400 million years. Start from here to here. It was all in terms of fish. All life was under the sea. But then, during this period, around 350 million years, the life started on Earth as well. Okay? And that's when, so we say that life was more like amphibian. So there were some animals which were able to live in the water as well as on the Earth. So submarine or subalien. So you see here, somewhere here, 350 million years, you have started seeing the green part as well. So this ocean, blue part, and then the green part. So life was evolving on Earth, on the surface as well. Yeah, please.
So this is half part of ocean and half part
No, not that way, not that way. It's not exactly half and half, of course. When, as I said, that since the life was till here at least, the life was all under sea, right? And then we came into the era of amphibians where the life could exist. So most of the animals, they were still living close to the water, right? So that means most of the life was even here, probably somewhere here, 300 or somewhere here. Most of the life was close to the sea area. Of course, there were animals on land, but they were all living close to the sea because they were amphibian. Using the right word, amphibian, right?
Yes, amphibians.
Yeah. And then around somewhere here, around 250 million years or somewhere there, that's when the big animals started coming in. Dinosaurs. And of course, they become bigger during around 200 million years, and they continue to live on Earth for quite some time. And that's called, the boundary here, that's called Cretaceous Tertiary. Right? That Cretaceous Tertiary is boundaries at around 65 million years, 65 million years. Any idea about this particular KD boundary? Anybody knows about it? There was something really big happening. Remarkable. Right. That's what there are several hypotheses, and one of them was, well, there was lots of restriction. Those who come, anybody from South here?
No, sir, everyone is from North Indian
Okay,
states.
anybody from Maharashtra here? Bombay, MP here, Maharashtra, Madhya Pradesh? No. Okay. So there is Deccan volcanism, right? Have you heard Deccan?
Yes.
And that actually happened sometimes 65 million years back. Of course, there are other hypotheses as well, whether it was because of meteorite impact, or the volcanism happened because of meteorite impact. Let's not go into that detail. But the biggest thing which happened was it wiped out those big animals, dinosaurs. So dinosaurs mainly disappeared from our Earth. That was about 65 million years back. And yeah. That's a good one. Of course, I'm not from that subject, but let me try if I can see something here. When did I don't see woolly mammoth here. Those elephants which were there in that period. I don't see in this figure. Do you see them here? No, of course it didn't unless it only says that mammals appeared somewhere somewhere around 200 million years. So that means mammals were, but they spread out quite dramatically. So I'm sure probably during that period mammals must have been there even in full years. But just Google it and you will find out. Somewhere here around 10 million years. Yes. That's when no, it's about 2 years. So no, it's about the ape came quite early, and but then the form in which we are, right, the species which were bifurcated, right. So they.
What is the genus now? Sir is talking about the Homo genus came late.
But then we are. How old are we? Sorry. Our ages?
Homo sapiens as the species, when the Homo sapiens.
So what is our age? When did we start? अभी क्या है कि आप लोग ना बिल्कुल अपने बारे में सोच रहे हैं। मैं तो I was born in 2010 आपको पता है। ओके, हम लोग तो थोड़ा बड़ी बात कर रहे हैं, राइट? आज के बारे में बात कर रहे हैं, आपकी लाइफ के बारे में कर रहे हैं। हम कब पैदा हुए मतलब हमारी जो हम जिस फॉर्म में आज की तारीख में हैं, वो इस फॉर्म में कब आए? 2 लाख साल? So, अगर इस क्लॉक को, इस अर्थ को, if I divide it in 24 hours, then our existence on Earth is only 9 seconds. Right? हम लोगों का existence इतना ही है। इस पूरी अर्थ की हिस्ट्री को देखें और उसको 24 hours में डिवाइड करें, if we divide it in 24 hours, then our existence on Earth is only 9 seconds. So we were born just 9 seconds before. So this also tells you that how fast we have evolved. हम लोगों का evolution is remarkable. I mean, so far it has been for good, but of course we also see that evolution can always be destructive in them. That's what we see here. And several places we see lots of things happening around. Anyway, let's not go into that detail. Okay, so that's how the life. That's when. So you all know when the earth began. You all know when the life began, right? And you all know when we began. Now, something.
And you said that life is from this ocean kingdom, right? This life is from ocean kingdom. But since the human life on land begins, how is this possible? Because the ocean species is present only on spaces, which is still different from humans.
I'm not getting you. After Joshua?
This is what is called as evolution. You know, this is called as evolution. The life started in ocean, but gradually it evolved. Then at the later stage, there were only unicellular,
Single cell.
organisms. Then multicellular organisms came into the picture.
Then vertebrates came.
And then slowly there was a phase of amphibians which can live both in water and land, and gradually they went to the land. Okay, so it didn't happen that the organisms who were living in ocean, they perished. No, they were also thriving. Okay, but some of them evolved into land organisms. Okay. Let us stand up and then ask.
जैसे कि यहाँ पर जो ना फिर भी एनिमल्स जो है वो पर्टिकुलर से ह्यूमन का यूज
Oh, okay. So you're trying to copy that politician जिसने कहा कि ये क्या बकवास है कि हम कभी बंदर थे तो जो बंदर है वो तो क्या आगे जाके आदमी बन जाएंगे. So that's the beauty of the evolution. So animals evolve more होते हैं. So when the apes were evolving, so there were several offshoots, and one of the offshoots was we evolved in that direction, and so it's not that all monkeys will ultimately evolve as human beings. No. So that evolution, वो जब evolve हो रहे थे तो उनकी several branches चल रही थी, right? And one of the branch got evolved into what we are now. So it does not imply that आज की तारीख में जितने बंदर आपको दिखाई दे रहे हैं आपसे 2 लाख साल बाद वो सब आदमी बन जाएंगे, ऐसा बिल्कुल नहीं होगा.
Mutation, you have heard about mutation now.
Yes, ma'am.
हाँ, तो एक ब्रांच कुछ किसी ऑर्गेनिज्म में म्यूटेशन हो गया, उससे आगे इवोल्यूशन हुआ.
आप सोचो कॉकरोच और जितने बहुत सारे जो स्पेशली many reptiles like lizard, right? They have not tortoise. They have not evolved much. ये ऐसे के ऐसे ही हैं millions of years. Cockroaches, I mean, imagine since millions of years they're like this. They have not evolved. So it's only we who evolved so fast. Yeah.
So like at the final stage, almost all animals came to the land.
No,
We still
it is
have.
not that oceans were empty after that. No, there were organisms.
You still
of
go fishing,
ocean.
right? You still go fishing.
Huh? One means in millions, a few organisms who were living in ocean, they had mutation. With the mutation, they got something by which they could live on land also. This is right. Okay. Others were like that only.
In fact, life on sea is we say that it is very majorly unexplored. We still don't have much idea about what are the variety of life under the sea. So it's only on land we have a fairly good idea about what are the species, but in the sea, the sea is, even now it is vastly unexplored. Okay, life. So then the next big thing which happened, life, after life, life was one of the biggest things. And there are a lot of views on how life started, why it is only here on this planet, why not on other planet. So what was so peculiar about this planet? So there's something called many scientists they think that it was just a chance, just the right thing, right ingredient, right at the right moment. The life started from very single-celled animals and then it evolved. So it was probably just a chance, and the chance is so rare that you don't see it elsewhere. Okay, so this is the biggest thing which happened on Earth is beginning of life, and it's just by chance. The second big thing which happened on Earth, which there is something called, I don't know how many of you are interested in mathematics, theory of everything, string theory of everything, right? So, similar to that, we have a theory here, plate-tectonics, which we say it is theory of everything. Whatever processes, dynamic process happening on Earth, plate-tectonics can explain. There is volcanism, earthquake, landslide, even floods, everything. It can explain almost everything. So plate-tectonics is kind of theory of everything. It's not like the same string theory of mathematics, but yes, plate-tectonics is so powerful that it can explain almost everything. And that's why, to me, it's theory of everything. And there is a debate that when did plate tectonics start on Earth? So these are, what I'm saying is these are very fundamental questions. So we have, a huge debate on when did plate tectonics start. There are several, opinion on it, and the earliest people say that probably life when the plate tectonics started, sort of immediately it coincided with the life on Earth, and that's why people say that in fact, it was plate tectonics which helped life to start on Earth, because the plate tectonics created that environment. It fixed the right amount of gases in the ocean as well as in the atmosphere. It provided right amount of nutrients. That's why the life started. But then, as I said, it's people debate quite a lot on this. And the earliest time they put is around 400, 500 million years back. But then there are people who say that, look, the life started sometime around 200, 300 million years back. But then there are people who say that, no, life started sometime around 100 million years back. So these are different estimates, so not the like different. These are different, numbers which people put for beginning of plate tectonics. The whole idea was, you know plate tectonics, right? What do you mean by plate tectonics? What does it say? So it says that now Earth has cooled down, right? And the Earth crust is divided into spherical shells, and all these shells or plates are moving with respect to each other. So to have a regular movement of these plates, what do you require? You require driving force, a regulated driving force. And what is that regulated? The dominant, very nice. Convection currents in the mantle. So when the Earth was absolutely hot, then that was not the right moment for upper layer to freeze, right? And things were very violent. But then when things became more regulated, when you had fairly good convection currents happening in the mantle, that's when the plate tectonics probably started.
So shouldn't the plate tectonics have started as soon as the upper surface of the Earth?
That's why some people put it at 400 million years, in fact. So there are something like, if I ask that when a baby is born, when is the time when it starts doing things on its own? When his behavior becomes more regular? When it starts thinking? When it starts, So there are several stages. So in here also, what is the criteria on the basis of which you want to say that when this thing happens, then I will say that it will start. Right? So if I, for example, in case of babies, we say that look, after 3 years, they start having their own memory, right? After 2 to 3 years, so that means whatever happened earlier is kind of it will not come. So should we start the age at the time, or should we start the age when he was born, or should we start the age when he was in the mother's womb? So कब start करेंगे इसको, कब से करेंगे? I mean, again there are debates कि भाई वो डॉक्टर लोग कहते हैं कि नहीं, वो तो जब बच्चा माँ के पेट में होता है, तो पहले हम लोग कहते थे बच्चा माँ के पेट से बहुत कुछ सीखता है. That's coming out true nowadays. A lot of a recent article in Science which tells about it. That look, it starts learning even mom's womb. So should we start the age from there? When should we start? So these are the questions which, whenever it comes to any dynamic living being, these questions are always asked. आप कब start करेंगे इसको, कब कहेंगे वो पैदा होगा, right? So plate tectonics, we have, here's the idea as to when exactly it starts. Because first we have to decide such gaps, that's right. So do we have a scale to say this is true? That scale doesn't exist. The scale, you only define that scale. And then on that scale you say this is true. Similarly here. Anyway. So coming to plate tectonics, that's the next big thing which happened on Earth. After life on Earth, the next big thing which happened on Earth was plate tectonics. And plate tectonics is the theory which was proposed is very, very new. Right? It came only in its formulated state, in its when it got nicely crystallized sometime in the 1860s. So our theory of plate tectonics was hypothesized only about 80 or 70 years back. So we have the science of Earth, or science of earthquake, or science of dynamic process is extremely, extremely young in that sense. Because we started learning only after 1960, 1970. But then, you know that there was something called continental drift, right? And what does the continental drift say?
That the single land piece of the fancy of is separate.
Excellent. So there was, and what does it say? How did it came on paper? How was it proved or disproved, or what were the evidences for continental drift?
The borderlands of the continent.
Very good. That's number one.
The movement of the tectonic plates.
Oh, you have come to plate tectonics. We have not come to plate tectonics yet. We are still in 1920s, 1930s, when continental drift was right.
The borders of the continents like
That's right. What else? Fossils. Right? So people found similar fossils. Right? On the one, the borders were matching. Yeah, of course. The number one, if you put all these continents together, they fit very nicely to each other. Okay? That's number one. Number two, the fossils. You find the South America and Africa, you have a huge Pacific Ocean in between. But even then, the fossils which you see, the kind of fossils which is here, this particular animal, it is found all here. So that means there was a time when these two masses were together and these animals could move from one continent to another continent. And similarly, there are several fossils like here, this particular animal, it was moving, and this particular animal, in this fauna, vegetation, it was found from South America to Africa to India to Antarctica to Australia. So these were the evidences for that look, these continents were together once upon a time. But then, because of some reason, they started separating out.
So like this is the only like the possible explanation of why these technologies are separated, or is it another
Okay, so let's go one by one, right? Let's finish this electrical part and then I'll complete, right? And then came world wars. World wars, all these wars are, especially those, certainly they were not good for any human being, for any humanity. But then world war, if you look at the discoveries, most of the discoveries, all of them, they happened during World War. Whether it's Thomas Alva Edison or anybody, just name it, and all of them were doing something else, and then they discovered something else. And one of the discoveries was seafloor spreading. So there was, in those days, it was not like naval strike, right? Most of the time it was the journey through the sea. So it's all these ships were moving here and there, fighting with each other, all these across the oceans. And what is required for ships to move? Navigation is one, of course. So the people were using astronomical observations for sure. But what else is required? You don't want to sit in a ship like Titanic, right? So you want some roads. What do you mean by roads in the sea? So you need to have chartered routes. What is chartered route? So at each place you know the depth of the ocean water, so that your ship does not collide with seamounts or with ridge or any other hydrographic feature on the surface. So then that means all these ships were equipped with sonar. They were continuously taking the measurements of ocean depth, so that the next ship can avoid those features which earlier ship has encountered, which earlier ship has mapped. So those are called chartered routes. If you happen to go by ship somewhere, then if you meet the captain, he will show you whether this route is chartered or if this route is not chartered. Okay. The other thing which, then there was some smart scientists also were involved in, and they were taking some magnetic measurements. And what they found was that look, they found, number one, in terms of bathymetry, that they found that look, there are some high topography feature here, high bathymetry feature here, which we knew that they are mid-oceanic ridges. But then people were taking magnetic measurements also across them. And what they found was that the measurements across, if this is mid-oceanic ridge, for example here, then the rocks are magnetized with different polarity, opposite polarity, away from the mid-oceanic ridge. And then there is symmetric pattern. So that means the rocks on either side, for example here and here, they are magnetized in the same direction. You know the magnetic reversals and polar bonding, right? So rocks are magnetized in similar direction from a fixed distance on either side of the mid-oceanic ridge. So this is, and then of course they knew the age of these rocks also somehow. So what does it convey? It conveys that there is something spreading, some material which is coming out, and these are all, and they were taking the temperature measurements as well. So these were high temperature areas. You know, if you lower down the thermometer, then you could see that these are mid-oceanic ridges where temperature is really higher than elsewhere. So what did it convey? It was telling that look, the sea floor is spreading out. The sea floor is spreading out. Somebody said continental drift. Then these 4 or 5 smart guys in the 1960s, they looked them together and they formalized the theory of plate tectonics. So the theory of plate tectonics has got ingredients from sea floor spreading and from continental drift. Now, let's come back to your question.
So my question was like that, you know, that all these things just match together, like set of the puzzles and all, and we find the 6 similar vegetation, flora and fauna there. That's why we are saying that all of them were combined. But it can be possible that at some point of the time in the past, the climatic conditions, the environmental conditions were same at all those places.
They were same because they were together.
But it can be that 2 parts of the world can have the same.
Very difficult. Until unless, you know, I mean, you can have, if you are in the equatorial region, you can have similar atmosphere, similar climate. But, you know, looking at Antarctica, right? Looking at condition in Antarctica and Africa, how could you have the same climate? So that means the position of Africa, which is today, or position of Antarctica, which is today, is different from the position it was earlier.
And as sir said, this was one evidence and the evidence of sea floor spreading.
Right.
Okay, so everything combined together, it solved that puzzle.
The idea was that when continental drift was, they were together, so what was the process because of which they spread apart? What was the process? And the process was sea floor spread. So there was mid-oceanic ridge which developed here, a crack which developed here, through which the new material started coming up, which helped in separating out these continents. Right? So that was sea floor spread. Sea floor, by the time we, you know, until mid-2000, we knew that there is something called subduction zone. But what subduction zone actually does, and how does it help in plate tectonic process, we didn't know. It's only after plate tectonics, when plate tectonics was formed, that okay, the new metal is coming from C2 spreading, the plates are spreading apart, so the piece and the volume of Earth is the same, has remained same. So the piece, the material which has come out, or the plates which are moving, they must be getting consumed somewhere. That's when the idea of subduction zone came.
Yeah, in the question about that. So judging by the map you showed of the fossils that we found, it is highly likely that the climatic conditions were not the same because there were different flora and fauna in different regions, right? They were not equally distributed. Then how can we say that they had similar climatic conditions and thus were close to each other?
I couldn't get your question.
Sir, if so close to each other, you said that they would have.
So what the
It is so close to each other, you said that they would have similar climatic conditions, right? These continents. But we did see that we have a very uneven distribution of flora and fauna going to the fossils there. Would it be more even if they actually had similar climatic conditions?
And says, repeat the last one.
Wouldn't the distribution of fossils be more even if each and every area had similar climatic conditions?
Well, how does we are into evolution, and something has evolved in certain stage. Now it has to spread out. So it will not spread out evenly or all through the world. It will find its own route. Own route means ROUT, right? So some migration path, some agent which will help it in its migration. So only in that way it will migrate. So the routes which you see here, for example, moving in Africa, India, and Turkey, right? So that was the finding a route as to in this direction it should spread out. That will depend on several factors, several agents. Which are external agents as well. So it's not that it's not that it's going to be spread out homogeneously, isotropically in all directions. It never happens that way, right? Look at our faces, right? So there are south, north, east, west. So people have remained. If they remain confined, you really see a distinction among faces. If we evolved and if we spread out like this, then all faces, all features should have been similar. But it doesn't happen that way. So we remain confined depending upon external agents and depending upon our own, the way we move. So Africans, they got remain confined there. Right? Oh. I can stop anytime whenever. Yeah. I never thought that it will take so much time to because of some good students here who are. Of course, some of them they didn't have good sleep in the night. So then, of course, people started looking at when electronics was happening. By the time, because of thanks to World Wars, we had fairly good idea about bathymetry of ocean. So we could make nice pictures like this, in which we found that there are mid-oceanic ridges, these are highlands, where you have mountains. And then the next big thing which happened was earthquake monitoring. And earthquake monitoring was not done to monitor earthquake. Earthquake monitoring was actually done to monitor nuclear explosions, nuclear tests which were done by several countries, especially NATO countries. So the idea was that let's put all these seismometers all over the world and analyze what other countries are doing. Are they testing some nuclear explosions? So that was a fundamental idea for installing seismometers. So that happened sometime in the 1960s, and then very fantastic thing which came out is like this. So they found that look, other than explosions, right, there are very fairly linear patterns which are nicely aligned with some certain mathematical and topographic features. For example, look at erosion ridges. So these red lines which you are seeing, these are basically earthquakes. Right? So all the earthquakes are concentrated here. There were earthquakes concentrated here in the Himalayan region that we are seeing right now. And of course subduction zones. So earthquakes were following certain patterns. And those patterns were matching with the bathymetry or topography of the region. So then people did a very clever thing. They just drew these lines which actually define the boundary of the plate. Right? So all these earthquakes, all these erosion ridges, so all these continents, this became one entity in terms of continental plate, African plate, and things like that. And of course, then people said that all these plates are moving into each other, and all these earthquakes, big earthquakes, they all occurred at the plate boundary. Majority of the earthquakes, they occur in the plate boundary, and very few of them they occur inside within the plate. So it's all because of plate tectonics, and plate tectonics is all because of world war. So for science, wars are good, but not very
So, the way I have read that Indian plate is splitting into two parts. So, what are the evidence?
Yeah, this is the news item which came just a few months back, and the problem is that the media is becoming a problem nowadays. That they put nowadays people want masala wala news, right? They don't want the simple news. And one of the saying media is that a sleeping dog does not make it to the newsroom. It's only a barking dog which goes to the newsroom. अगर वो कुत्ता कहीं में सो रहा है तो उसकी कोई खबर नहीं बनेगी, लेकिन जब कुत्ता वो भौंकना शुरू करेगा, काटना शुरू करेगा तो उसकी न्यूज़ बन जाती है. तो यही चीज इस वाले केस में हुई कि there are geological process called delamination, tearing, underplating, and these processes, all of them, they happen at plate margins. We have seen it in Oman, we have seen it in Iraq. This time they found it happening in the Himalayan region. The one I'm talking. I'll come to that later part. So this time they found that there's something happening below the Kirtan plateau, and then they said that look, Indian plate is delamination, this tearing going on, and it will split the Indian continent. Then these media people, they started adding things. It will split India into two parts, and if it is going to happen tomorrow, as if all of us are going to die, as if Andhra Pradesh, Telangana, Odisha will get separated out from Madhya Pradesh and Rajasthan and Gujarat. That's not going to happen for sure. I mean, these are geological processes which happen over millions of years. And I said on this clock of 22 hours, we are 9 seconds long. And these geological processes occurring over millions of years. For sure it's not going to happen in my the human being life can take millions of years. That's number one. Number two, a question that whether Navada's home lineament is also segmenting the brain in two parts, lot of organism, lot. Well, there are a lot of papers on it, few papers on it. But honestly speaking, we don't see the evidence of it. We don't see, we still see a united India. We still see India moving together, moving in one direction with similar thing. I know I can spend more time, but probably get bored. Yeah.
As Ram has said, there are also theories that some part of the continent of Africa.
Oh yes, you're right. Sure, right. Beautiful. That's right. Oh, it's here. Actually here. So that's not new. Here, which is there's a depth system which is developing, and it's not that it has developed. It has started now. This process also started a few years back, but it's only now that we have started paying attention to it. We have started seeing the evidence of it. So that's why we have started talking about it. So this, for sure, there's something called Somalia plate, which will come out of Africa, right? Somalia, which will have Somalia and these Madagascar. So all this will come out and it will start moving towards India. But it's not going to happen in our lifetime, right? You will never get a chance to go to Madagascar in your lifetime. Yeah. Okay, so we say that the tectonics say that these plates are rigid, right, and they are moving. And what they say, the deformation generally happens on the plate boundary. But because Earth has gone through several episodes of several processes, so it's not that, for example, I don't know how much you have traveled. If you which place you come from? Algora. And how far you have gone? Have you gone to Delhi? Good. So when you go to Delhi, Algora, what is it that you see? What do you see? So you see, I'll make it simple. So you come from Algora, Algoni, Kartavan, right? And so from mountains, you have suddenly come to Indogenic plains, plain area, all fertile land. Then when you go to Delhi, you start seeing hills. Very lovely hills, right? And if you've gone to, I'm sure you must have gone to those malls which are there in Gurgaon area, right? So, or close to it, you start seeing those very lovely sandstone beds. So what do you see? The Indian plate is also not homogeneous. So you have different rock types from place to place, and you have different structures. So the plate is not homogeneous. If the plate is, because this is homogeneous, if I push it, it will act as a single unit. But if it has got integrity within it, right, then it can deform within itself. But since this entire planet is all one planet, it's absolutely homogeneous. So if I push it here, the whole table will move in such a way. But if I cut it here, if I fracture it, if I add some material here, and then I push it, I'm sure there will be some internal deformation. That's what happens to the plate. So the plate is not right. So the plate, though it's a single unit, but it has got lots of capacities. It has been fractured several times, glued several times, because of which it has got these zones. You have a fracture in your hand, right? In your childhood. I'm sure you must have fallen. अब वो फ्रैक्चर तो हील हो गया, लेकिन your parents keep telling that look बेटा इसका ध्यान रखना, इसको जोड़ मत डालना, because there is a weak link here. It is absolutely healed up, right? लेकिन then there is a weak place, weak zone in your body, and those weak zones are nothing but those places where all these places within the plate, Jabalpur plate, Kachar plate, Gulabdeh plate, or Nadu Bikumat Major plate, but majority of the earthquakes are hard on those weak plates. Those plates where Indian plate got injured, right, in its childhood or its journey. But because you're continuously pushing Indian plate, so it gets deformed. Okay, so yeah, I'm done. I'll wrap up now. Yeah, I'm sorry, I'm really halfway, but I'll stop it. The basic idea was to come to you to take it from this level. So then we said that okay, everything is now together, sequence coding, alternative, plates are moving. So then we came to this picture. That all these plates are moving in respect to each other. The Indian plate is moving towards northeast, and then in the process it is colliding with the Eurasian plate in the north. That's why we have Himalaya, and that's why we have what we have recently. Right? So I think I will end here. I mean, this is just a cartoon to show. It's not the just to show how Indian plate move towards. So that's how the Indian plate is moving, right? And I think that's all. I'll stop here. I'll not go into further how the plates occur, how what is the elastic event. Elastic event theory is the next big thing in our science. The biggest technological innovation applied in math science is the use of GPS in such projects. All their satellite system, all their missile system, or defense system, it all works on that simple how do you position yourself, how do you know where you are, and that's all because of GPS. And there was time when the GPS was not there before 1980s, and then of course there was missile system at that time, but then they have going here and there, but now you have precise position and you know where to hit, how to hit, whether it's the base, so you know where exactly you need to hit, and you can track your missile, you can track your most to the place, and that's all because of navigation system. So the next big thing which happened in earth science, and the most beautiful thing was its application in earth science. That you could use GPS to a precision of millimeter level. I mean, the two points which are a millimeter apart, and I can distinguish between them. So that's the next big thing which happened in earth science. I think I'll stop here. Thank you.